All right, so here we go. We got chapter 8, working with tubing and piping. Number 1, copper tubing manufactured specifically for circulating refrigerant and refrigerator systems is called blank ACR tubing, which ACR is actually air conditioning and refrigerant tubing, so that does make sense. And that's going to be on page 129. Number 2, what is the outside diameter? 1/4, a quarter inch ACR tubing. I went with A, 1/4 as well. This is between page 129 and page 130. I used the chart as well. On the 129, it says that copper is, the nominal is the outside minus 1/8, but we're not dealing with copper, we're dealing with ACR. So it's designated by the actual outside. So based on the chart, the quarter inch also equals 0.25, 1/4. And this is saying that 1/4, in my opinion, diameter is also gonna get for 1/4 tubing, but that's my answer for that is A, 2. All right, 3, soft copper tubing has been hardened repeatedly by bending or hammering is referred to as C, work hardened. That's on page 130. That's on page 130. I don't know why I put 132. I think it's... All right, moving on. Number 4, which of the following is... maybe it's not 130. It should be 130. Number 4, which of the following is not a type of plastic pipe? That's going to be JIC. Not plastic. The others are ABS, PVC, and CPVC. Those are all inside page 132, in that final sentence at the end of that paragraph. Number 5, steel pipe is generally not used to circulate refrigerant except in the systems that use blank as refrigerant. That's A, ammonia, page 133. Yeah. All right, number 6, when cutting copper tubing with a hacksaw, what practice should be followed? This is between 134 and 135. I put D, all the above. All right, number 7, which is the recommended method of removing an external bending spring from tubing after tubing has been bent? C, twist the spring, page 137. Most flares, number 8, most flares on ACR tubing are made at an angle of blank 45 degrees. That's on page 139. Which of the following is the first step when flaring tubing? B, place the flare nut on the tubing, page 139. The difference between double flares and single flares is that double flares have double the thickness of metal, page 139. 11, flared quarter inch ACR tubing uses blank flare nut. That's quarter inch, that's what I put, page 141. An important reason to prevent exposing some refrigerants to extreme heat is that they produce an extremely dangerous byproduct called phosphine gas. That's page 143. 13, which type of torch flame is recommended for brazing, produces relatively little noise and does not generate smoke? That's going to be B, neutral, 145. 14, an important phenomenon in soldering and brazing is the movement of a liquid substance between two solid substances due to the adhesive forces of solids, which is called capillary action, 145. Metal that is being soldered must be blank when soldering. Hot enough to fully melt the solder. That's 146 to 147. Before soldering tubing, it is important to blank the metal parts. First clean and then add flux to. That's page 147. There's a step chart there, step chart. 17, the major temperature that separates soldering from brazing, 840. I've done some brazing. I haven't done anything soldering, but I've done brazing to combine the pipes together, the copper pipes. That's on page 147. The answer is B, 840 degrees Fahrenheit. 18, never use blank when purging tubing to remove unwanted dirt and moisture from a refrigeration system. Oxygen, that's 149. With the flame kept on the metal but away from the brazing filler material, what ultimately indicates the correct brazing temperature has been reached? B, the flux turns puffy and white, page 149. Number 20, why does a joint need to be cleaned after brazing? D, to remove flux, which may corrode tubing, page 150. 21, the length of an overlap of two pieces of tubing joined by swaging should be equal to blank of the tubing, the outside diameter, 8, 151. 22, the proper connection of ACR tubing into another ACR tube of the same size that has been swaged involves, this one I didn't know. I put A, brazing, 151. I just stuck with that because we did this. This little picture right here that I drew. See, these two were equal at point, but there's a device that you use. It looks like a metal stick and it sticks into this and it expands it slowly so that two equal pipes can equal each other by opening up this. And then we did that so that we could solder. So that we could braze. That's why I put brazing, because I did that in person. So I'm putting A brazing, yeah. 23, pipe schedule refers to a pipe's blank wall thickness. That's D wall thickness, that's on page 152. 24, a street fitting is an angled pipe or pipe tubing fitting that has a street fitting is an angled pipe or tubing fitting that has one male end and one female end. That's on page 153. Number 25, what type of solvent cement can be used with Schedule 40 PVC pipe and fittings under 6 inches? I went with light duty PVC cement, page 154, C, light duty PVC cement. Critical thinking. All right, number 1, explain the reason why ACR tubing should be cut using a wheel type cutter rather than a hacksaw. What could happen to the HVAC system using tubing cutting with a hacksaw? All right, so I actually have a little bit of a video right here. So if you look, right, I'm using a wheel type cutting tool, so it's not a hacking tool. So basically what it is, you insert the tubing inside of there, and then I tighten it with a little rotation where the handle is. And what's happening is that there's a wheel inside the top of this device that you put just on enough kind of to graze it, and then you're gonna rotate almost like you're fishing, you know? Either, it doesn't matter which way you go, forward or backwards. I mean, it might if you're there, but you'll know when you're in class, and you're gonna go over it several times. You're not gonna rush it. If you rush it, you'll bend it because the copper is very sensitive. So what happens, that's why you use it, because if you use the hacksaw, the amount of pressure you're applying to the hacksaw is going to dent the entire pipe in that area. And if you do that, it's gonna mess with your entire HVAC system because it's gonna cause a blockage. It's gonna pin down that diameter on the inside. You're not gonna want that. All right. So I put, this is on page 133 as well. So wheel type blank, wheel type is for small tubes made of softer metals like copper. Hacksaw will bend and crush a smaller copper tubing, which cause problems inside the entire HVAC system because you're pinning down the piping. Number 2, why is a large radius preferable when making bends to soft ACR tubing? 136, larger radius, number 2 on page 136, larger radius reduces the amount of flattening when bending. That's the pinning that I'm talking about. It's going to start to crush itself. And then here's the little device right here. So this device right here, you put the copper tubing in, and then this right here, it looks like a crossbow because there's a trigger underneath it. These two rubber pieces at the top, they're at the top, and then the copper goes in between in that little crescent you just saw. And as you see, it had a measurement on 3/4. So each one of these tops, they're detachable. They match up to whatever the piping that you is. So as you pull that trigger, the crescent is going to push up. These stay stationary, and it pushes up every time you pull the trigger. It pushes up, and it slowly makes that bend that you want, all without any type of electronics. Just boom, boom. So you want to prevent any type of flattening from happening, and which could also back up your HVAC system, cause extra stress. You don't want that. All right, that's so how did I word the answer? So yep, we already told you. All right, 129, page 129. Why would the flaring cone on a flaring tool be slowly tightened and then backed off repeatedly to form a flare? All right, so this is to create a proper fitting, not too small, not too large, and it prevents creating thin walls of the tubing. So instead of just pushing it in all the way, as in getting, you push in a little, you back off. You push in a little, you back off. And you do that so that you don't damage the actual product that you're working on. So instead of just like I pulled that trigger, I went all the way. With this device, with this process, you would click it, then completely back off, re-engage, and do that until you get the fitting that you want. All right, so why would an oxyacetylene torch be more effective in brazing than an air acetylene torch? All right, reasons, this is on page 143. Most effective. All right, so the oxyacetylene is more effective for brazing. It brazes quickly, and it reduces the amount of heat transfer to the copper, which could affect the integrity of the metal. So it does what it needs to do without heating the rest of the pipe that you're working on, which could cause problems. All right, so number 5, why should a brazing filler rod be applied to a joint at a 30 to 45 degree angle? So that one's going to be number 5, page 149. 30 to 45 degree angle helps draw brazing material into the seams. That's why you do it. It helps draw it into the seams. All right. Fitting. All right. Number 6. When running piping and dealing with an offset or an other configuration, explain the benefits of using street fittings instead of standard fittings. All right, so last question, number 6 on page 153. Street fittings reduce the number of fittings used for offsets and other configurations. All right, good job.